So for this activity, the instruments and accessories that we need are range poles, measuring tape, markers such as chalk and marking pins, and plumb bobs. So for the first activity, we are going to determine the area by base and altitude. So first, the instructor assigns the locations of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. So for step 2, the chief of party divide the polygons into 3 triangles by taking into considerations that the divisions should easily be measured. Name the triangles as A1, A2, and A3. Measure the base of the first triangle chosen in the polygon using tape. Determination of the altitude is part of the taping operation, which will be discussed by the instructor. For step 5, record the length of the base and altitude on table 3.1. To get the area of the triangle, use the formula 1/2 times base times altitude. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of the areas A1, A2, and A3. So for this polygon, A1 has an altitude of 2.3 meters and the base of 5.85 meters. So for A2, we have the altitude of 3.2 meters and 6.70 meters. For A3, we have an altitude of 2.55 meters and 6.70 meters as the base. So for the computation, we are going to use the formula 1/2 times base times height or the altitude. So for A1, we have 6.7275 meters squared. So for A2, we have 10.72 meters squared. So for A3, we have 8.5425 meters squared. And then we are going to get the summation of all 3 triangles. And then we have a total of 25.99 meters squared.
Letter B. Area determination by 2 sides and an included element. Number 1. The same field described in letter A, area determination by base and altitude will be used for this method but change the designations on the corners. For example, use capital letters F, G, H, I, and J instead of capital letters E, B, C, D, and E. Number 2. Divide the polygon into 3 triangles. As you can see, the polygon with so-called pentagon can be divided into 3 triangles. Number 3. Measure any 2 sides of the first triangle chosen and record those measurements as sides small letter A and small letter B. Number 4. Determine the included angle between sides A and B and record this on table 3.2, area determination by 2 sides and an included angle. To get the area of the triangle, divide the product of side small letter A and side small letter B and sine of the included angle to 1/2. Number 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
C. Area determination by Heron's formula. 1. The same field described in A, area determination by base and altitude will be used for the method, but change in designation on the corners. Use K, L, M, N, and O instead of A, B, C, D, and E, and F, G, H, I, and J. Divide the polygon into 3 triangles. Number 3. Measure all the sides of the first triangle chosen and record this measurement as sides A, B, and C. Number 4. Determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2 to determine the area of the triangle. Substitute the value of the semi-perimeter side A, side B, and side C, the equation, Heron's formula. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon to determine the whole area of the polygon. Take the summation of areas A1, A2, and A3. When we use the equation, area is equal square root of S multiplied by S minus A, S minus B, S minus C, where A and B and C are the sides of the triangle and S is the semi-perimeter. The equation is known as Heron's formula. Let us solve first the semi-perimeter of the first triangle. Add 4.5, 4.75, and 6.5 and divide it by 2, you will get 7.95. And then sub those values to Heron's formula, you will get 10.68. And repeat the process of for triangle 2 and 3, you will get 9.67 and 6.50 squared respectively. And to get the total area, just take the sum of the area of every triangles and you'll get 26.25 meters squared.